Welcome to One Chemistry. Always try to do your best. Now let's see 100 concepts in organic chemistry. We are seeing it as episode. This is the episode number 2. Here we solve 5 problems step by step, mostly part B questions. Stay tuned for the solved problems. Let us see the question number 1. They given the bicyclic compound which has 2 bridged carbon. Methyl is below the plane and you have alkene and ketone. They ask the configuration of 1 and 4 position. The possible choices are obvious, whether both are R, both are S, or 1 is R, 4 is S, or 1 is S, 4 is R. Here you have to understand that the question is about the bicyclic molecule and its configuration inside it. The answer is A. Let us see how. Here, to identify the configuration, better you write the molecule separately, the 2 chiral centers. So write the 2 chiral centers separately, 1 and 4. If you redraw nicely, you have to draw the configuration and its priority. If you look at the priority, carbonyl has first priority. Then you have alkene because it is attached with double bond. Then you have ethyl, then methyl. So 4th group. Here, according to the rule, 4th group should be backside. Here the 4th group is backside, so the configuration is same, which is clockwise. The configuration is R, so 1 is in the R position. Then the 4th one, we write it separately, so the first position is alkene here, because the carbonyl is away from one carbon. So alkene is first, carbonyl is second, and third is ethyl, 4 is hydrogen. Here the hydrogen or 4th priority group should be on backside. If the lowest priority group not in backside, the configuration will be reverse. So the configuration here 1, 2, 3, which is S position. So if you write it reverse, it is R. So 4th also R. So the answer is A, which is 1R and 4R. Here which concept you have to know? The concept here is low priority group should be always on backside, and you have to imagine the configuration in the bridged structure. Then the question number 2. The starting metal is cyclohexane in alkene form. You have acid in the side chain. You are using iodine and Ki and sodium carbonate. Here 4 choices are given. The products are ring closed and ring open reaction. Ring closed one, the position of hydrogen and iodine in question. Whether the rings are in syn form, or the ring and iodine in the trans form, or the simple CO2 elimination and iodine attachment, or the iodine attachment in the alkene. So there are the 4 possibilities. So from the reactant to product, you might think of regioselective reaction. Most probably the ring closure here. The answer is A. Let us see how. Starting metal you are having acid, you are using the base. Base abstract the proton, you have the anion there. Next step you are using the iodine. Iodine what really doing is, it just adding in the syn fashion, just a 3-member ring like cyclopropane. For our convenience, we write it on below side. You can write above also, the answer will be same. Next up, we have to think of ring opening because you have charge inside and it has to be quenched. So the attack is definitely from the opposite side. So it's a SN2 kind of mechanism. So iodine is bulk. So O is attack from above. You have the O above, iodine below. So if you redraw perfectly, the iodine is below, hydrogen definitely will be below. Ring closure is concerted mechanism. So answer is clearly A. Here you have to learn 3 important things. One is iodine addition is syn addition. Second thing is SN2 attack, which is on the backside attack. So the inversion in configuration happened there. Then the third thing, cyclic addition is always concerted. Both ring attachments should be syn to each other. Then the question number 3, they given 2 compounds. The 2 compounds, methyl above, hydrogen below, methyl above. The ketone position also switched. The question is whether they are enantiomer or both are same, or they are diastereomers, or they are regioisomers. So the question is really about your understanding of 3D structure. Because the real life molecule can be above or below or rotated, you cannot specify the molecule, it should be above or below. Above or below is our point of view. The answer is B. Let us see how. The starting metal you have methyl above, hydrogen below. If you just do 180-degree rotation, you got the same molecule which is given as a choice there. So the molecule is just rotated, you have the same molecule. So the answer is clearly B. What concept you have to know? Rotated molecules are identical. Why? Because during the chemical analysis, molecule can be in any direction. For example, NMR, you have the molecule in any direction. So you have to imagine the molecule either rotated or above or below, anyway, all the directions. Then the question number 4. The starting metal you having orthoallyl ether, then you are heating, they ask you to find the product. The product can be the allyl group moved to ortho form or para form, or it can be in any direction with mixture or simple alcohol formation. So from the reactant to product you might understand rearrangement is occur and the continuity or selectivity of the allyl group is important here. The answer is A. Let us see how. The starting metal you have allyl group. Let us redraw it perfectly for the rearrangement. So we redraw it and there is a possibility of 3,3 sigmatropic rearrangement. The allyl group switches here, you have the bond there. Then there is a creation of aromaticity. Then you have the compound which is ortho substituted. Here the driving force for the alcohol formation is aromaticity. Because aromaticity is a stable one, H leaves and create the aromaticity through heat-enol tautomerism. So the aromaticity is the driving force here. Here, why the para product is not possible? Since the hydrogen is available there, the product end with a stable product. Suppose you don't have ortho hydrogen as given here, both are methyl substituted, no ortho hydrogen means you have it proceed to para. So here the concept you have to learn is the rearrangement, 3,3 sigmatropic rearrangement is stopped when there is a stable structure formation. If there is no hydrogen here, it will go to para. Here only ortho. Then the question number 5. The starting metal heat on you are using the diol there which is ethylene diol. You are having the closed 5-member ring formation. They ask you to find the reagent. The reagent is BF3 or reagent is base or reagent is tungsten lamp or reagent is peroxide. Here the question is indirectly asking the role of 1,2-diol there through which catalyst it can be activated. The answer is A. Let us see how. Here BF3 is the catalyst. Let us see how. Because we are activating the carbonyl through BF3. So BF3 kind of coordinating with oxygen and you are reacting with diol there. Diol attack the carbonyl there because it's just a nucleophilic attack and the ring will close. OF3 will eliminate there. What is special? Why this question is there? Because here you have to learn the concept of protecting group. Here 1,2-diol protect the ketone. It's a chemoselective protection, meaning it won't allow the carbonyl to involve in the reaction through the 5-member stable ring formation. So here the concept is diol group protecting the ketone from the any other reaction. So here the concept is diol group protect the ketone from further reaction. It provides chemoselective protection. That's all from this episode. I hope it was useful. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.